Our planet is a place of constant change. From the shifting of tectonic plates to the ebb and flow of ocean currents, Earth is in a perpetual state of flux. This dynamic nature is what makes our planet so unique and vibrant. Seasons shift, temperatures fluctuate, and weather patterns dance across the globe. These changes are not random, they follow a rhythm, a pattern that has been observed and studied for centuries. The interplay of these elements creates the diverse climates and ecosystems we see around us. One of the most significant influencers of these changes is a climate pattern called the El Niño-Southern Oscillation, or ENSO. This phenomenon is a cornerstone of climate science, affecting weather patterns on a global scale. It is a complex system that scientists have been unraveling for decades. ENSO is a cycle of warm and cool phases in the Pacific Ocean, phases we know as El Niño and La Niña. During El Niño, warmer ocean temperatures prevail, while La Niña brings cooler conditions. These phases are not just limited to the Pacific, their effects ripple outwards, influencing weather far and wide. These natural occurrences are not mere blips on the radar of our planet's climate system. They are integral components that drive significant changes in weather patterns. The impact of ENSO can be seen in the form of altered precipitation patterns, temperature anomalies, and even shifts in storm tracks. They are powerful forces, capable of altering weather patterns across the globe, bringing floods to some regions and droughts to others. For instance, El Niño can lead to increased rainfall and flooding in some areas, while causing severe droughts in others. La Niña, on the other hand, often brings the opposite effects, creating a delicate balance in the global climate system. Understanding El Niño and La Niña is crucial to comprehending the intricate workings of our planet's climate. By studying these patterns, scientists can better predict weather events, prepare for natural disasters, and develop strategies to mitigate the impacts of climate change. The rhythm of El Niño and La Niña is a testament to the interconnectedness of our planet's systems, reminding us of the delicate balance that sustains life on Earth. El Niño, Spanish for the little boy, is the warm phase of the ENSO cycle. It refers to a period when the surface waters of the central and eastern tropical Pacific Ocean become unusually warm. This warming disrupts the normal atmospheric circulation patterns, leading to a cascade of effects felt around the world. During an El Niño event, the trade winds that typically blow westward across the Pacific weaken or even reverse direction. This allows the warm water that usually accumulates in the western Pacific to flow eastward towards the Americas. The consequences of this shift in ocean temperatures are far-reaching, impacting weather patterns thousands of miles away. La Niña, Spanish for the little girl, is the cool phase of the ENSO cycle. It is characterized by unusually cold sea surface temperatures in the central and eastern tropical Pacific. Like its warm counterpart, La Niña disrupts normal weather patterns, but with its own set of consequences. During a La Niña event, the trade winds strengthen, pushing warm water westward, and allowing cold water to rise to the surface in the central and eastern Pacific. This intensification of normal conditions leads to a different set of global weather anomalies than those observed during El Niño. While both El Niño and La Niña disrupt the normal equilibrium of our planet's climate system, they do so in distinct ways. These phenomena are part of a larger climate pattern known as the El Niño-Southern Oscillation, or ENSO, which significantly influences global weather and climate. El Niño and La Niña are essentially opposite phases of this climate pattern. El Niño is characterized by the warming of sea surface temperatures in the central and eastern Pacific Ocean, while La Niña is marked by cooler than average sea surface temperatures in the same region. El Niño typically brings increased rainfall to the western coast of South America, often leading to severe flooding and landslides. This can have devastating effects on communities, agriculture, and infrastructure. At the same time, El Niño causes droughts in Southeast Asia and Australia, which can lead to water shortages, crop failures, and increased risk of wildfires. The economic and social impacts of these droughts can be profound, affecting millions of people. La Niña, on the other hand, often leads to drier conditions along the west coast of South America. This can result in reduced water availability and stress on local ecosystems. Conversely, La Niña brings increased rainfall to Southeast Asia and Australia, which can enhance agricultural productivity but also increase the risk of flooding and landslides in these regions. These contrasting effects highlight the importance of understanding the differences between these two climate phenomena. By studying El Niño and La Niña, scientists can better predict their occurrence and potential impacts, helping societies to prepare and adapt. Predicting whether an El Niño or La Niña event will occur and how strong it will be is crucial for farmers, water resource managers, and policymakers. Advanced computer models and satellite data are used to monitor sea surface temperatures and atmospheric conditions, providing early warnings of these events. For farmers, understanding these patterns can inform planting and irrigation strategies, helping to mitigate the risks of crop failure. Water resource managers can use this information to plan for potential shortages or surpluses, ensuring that communities have access to the water they need. On a broader scale, communities around the world can prepare for the potential impacts of El Niño and La Niña by reinforcing infrastructure, developing emergency response plans, and raising public awareness. By taking proactive measures, societies can reduce the adverse effects of these powerful climate phenomena and enhance their resilience to future events. Section 5: El Niño and La Niña's global reach. The influence of El Niño and La Niña extends far beyond the Pacific Ocean basin where they originate. These climate patterns can impact weather systems across the globe, altering jet stream patterns and influencing temperature and precipitation patterns far from the tropics. For example, during an El Niño event, the Pacific jet stream often shifts southward, bringing wetter conditions to the southern United States and warmer, drier conditions to the Pacific Northwest. La Niña events, on the other hand, can lead to colder, snowier winters in the northern United States and increased hurricane activity in the Atlantic. Section 6. Predicting the unpredictable. 2025 and beyond. Predicting the future of El Niño and La Niña is a complex task. These climate phenomena, which significantly influence global weather patterns, are driven by a multitude of factors, including ocean temperatures, atmospheric conditions, and even volcanic activity. The interplay of these elements makes forecasting their behavior a challenging endeavor. These climate patterns are influenced by a myriad of factors, and their behavior can be unpredictable. The intricate dance between the ocean and the atmosphere creates a dynamic system that can change rapidly, leading to sudden and sometimes severe weather events. Understanding this complexity is crucial for accurate predictions. However, scientists use sophisticated computer models and historical data to monitor ocean temperatures and atmospheric conditions, providing forecasts and early warnings of potential El Niño or La Niña events. These models incorporate vast amounts of data, from satellite observations to ocean buoy readings, allowing researchers to simulate and predict future climate scenarios with increasing accuracy. As of January 2025, we are in a neutral ENSO phase. This means that neither El Niño nor La Niña conditions are currently present, leading to relatively stable weather patterns. However, this neutral phase can shift, and scientists remain vigilant, continuously analyzing data to detect any early signs of change. However, it is still too early to say with certainty what the year holds in store. The transition from a neutral phase to either El Niño or La Niña can happen quickly, and the impacts of such a shift can be profound, affecting weather patterns across the globe. From droughts to floods, the consequences of these climate events are far-reaching. Continued monitoring and analysis of ocean and atmospheric conditions are essential for predicting any potential transitions to El Niño or La Niña and their potential impacts on global weather patterns. By staying ahead of these changes, scientists can provide valuable information to help communities prepare for and mitigate the effects of extreme weather events. The work being done today lays the foundation for a more resilient future, where we can better anticipate and respond to the challenges posed by our ever-changing climate. Section 7. The importance of understanding ENSO. The El Niño-Southern Oscillation is a powerful force that shapes our planet's climate. Understanding ENSO is not just an academic exercise, it has real-world implications for people, economies, and ecosystems around the globe. Farmers rely on ENSO forecasts to make informed decisions about planting and harvesting. Water resource managers use this information to plan for potential droughts or floods. Coastal communities need to be prepared for the increased risk of storm surges and coastal erosion during El Niño or La Niña events. Section 8. Monitoring ENSO for a better future. Monitoring and predicting ENSO is crucial for building resilience to climate variability and change. By understanding the potential impacts of El Niño and La Niña, we can take steps to mitigate risks and capitalize on opportunities. International collaborations and advancements in climate modeling and forecasting are improving our ability to predict and prepare for El Niño and La Niña events. This information empowers communities around the world to make informed decisions and adapt to the ever-changing rhythms of our planet's climate. Section 9. Conclusion. Living with El Niño and La Niña. El Niño and La Niña are integral parts of our planet's climate system. These powerful forces remind us of the interconnectedness of our world and the importance of understanding and respecting the natural processes that shape our lives. As we move forward, continued research, monitoring, and international cooperation will be essential for predicting and adapting to the challenges and opportunities presented by these ever-present climate phenomena.